Hello, everyone, and welcome to SSI Meetup. I'm James Monaghan, and along with Alex Brukshat, I'm pleased to be co-hosting this series of webinars sharing important content related to the self-sovereign and decentralized identity space. This is the second session that we've held since our brief COVID hiatus. As a reminder, rather than doing them live like we used to, we're now recording them. So the format's a little different to what some of you may remember, but the content is no less interesting. And that's definitely demonstrated by our guest for this session. We're very lucky to be joined by Otto Mora from the Polygon ID team. I'm really excited to hear what he has to share with us. But before we dive in, we always briefly review what the objectives of the SSI meetup are. So if we just bring that slide up. As you'll know, if you've watched any of the previous 61 videos, we're here to empower the global community that's working on self-sovereign and decentralized identity. These sessions are open to literally anyone who's interested in the topic. We love to hear from them and also to share with them. And all of the content is shared under a Creative Commons share-alike license. And what that means is that you can reuse any of the material that Otto's about to share with us today. You just have to give credit back to him and to SSI Meetup when you do so. And the hope is that this way we can maximize the number of people who this is useful to and achieve our mission of accelerating adoption of SSI. So that's quite enough from me. I'm really excited to hear what Otto's got to share with us. So Otto, if you dive in, begin with a brief intro of yourself, and then we'd be really excited to hear what you've got to say.
Perfect. Yes, thank you, James. Appreciate it. And I'm honored to be here. Really, it's great to be contributing to SSI Meetup and hopefully spreading, the usage of SSI and verifiable credentials, so that we can see more and more of it around the world. My name is Otto Mora. I'm from Costa Rica, and I have been working for Polygon since September. Been working previously in blockchain for a number of years. And now lucky enough to be working at the intersection of blockchain and identity, which is something that is very close to my heart and something that I think is more and more relevant nowadays as we have more and more bots out there and artificial intelligence becoming more sophisticated. So hopefully this will be a step in kind of enabling some countermeasures to that and bringing users to be in control of their data. Yes, so that's enough about me. Maybe a little bit about Polygon ID, and a little bit about the, like the agenda that we're going to follow today. So, Polygon ID, just an overview of what it is and what verifiable presentations leveraging ZK proofs look like. The DID Polygon ID overview of our DID method, how ZK proofs are generated, credential issuance methods, which we have a few of them, also some identity management features that our DID method has, and finally, how we manage Merkle trees and how claims are revoked. And then, towards the end, just a brief plug on what is available today as far as software and, the open source release, and Q&A as usual for SSI Meetup. All right, so just a teasing question. Have you or a friend ever done this, right? Have you ever, kind of wanted to selectively reveal data about yourself? Maybe, somebody wanted to take a picture of somebody's business card, but you didn't want to reveal the full information that was there, or, you're just not comfortable in sharing your full information, right? So we think that this means that people want selective disclosure in the physical world, right? That's something that's desired, but they just don't know that currently you can already do that in the virtual world, thanks to the magic of zero knowledge proofs, right? So we think this is something that becomes more and more relevant. I still don't fully think that people value privacy enough, and that's beginning to change, but we still have some ways to get there, and it's going to take a while, but I think it's going to become more and more relevant over time. So kind of centering in on what we do in Polygon ID and how we do verifiable presentations leveraging ZK proofs, right? So our sort of DID method is sort of user-centered and wants to prove information in a private by default manner, right? That's like the main thing we want to try and offer. So you have a verifiable credential. The credential is going to state some attributes about yourself, perhaps your date of birth, maybe your credit score. You know, it's going to say what country you were born in. It's going to say what club memberships you have. You know, it might have a number of attributes, and you're going to interact with the verifier as you would normally do in an SSI setting. But this verifier will, instead of getting you the full credential data or a set of that, will ask for a set of questions, which we have implemented in a ZK query language. And this query language enables you to query the information about those credentials. Then you take that query, and then you're able to generate from your device. That could be a smartphone where you're holding your credentials, or it could be a browser extension where you kind of have your credentials stored if you're using a browser-based wallet extension. And you can generate this proof from that device, right? That zero knowledge proof is going to leverage some circuits that are publicly available as well, kind of referring to our ZK query language, and you can then privately verify that information, right? So these ZK proofs are derived from your verifiable credential, and the verifier can verify that information without, you know, necessarily knowing who is the holder of that identity, right? Just satisfy the question. Just know, are you older than 18? Just know, are you a member of this club? Or maybe a more open question, such as a range question, is your credit score between 500 and 600? Or other, you know, types of questions. So this is sort of like the heart of what we do, and we try to do it in such a way where you have a pluggable set of ZK proofs that you can generate. We're starting with a base, but you can, you know, over time ask more and more detailed and nuanced questions. Now, having said all of that, and while we highly encourage the usage of zero knowledge proofs, that is not the only way in which you can reveal information. So selective disclosure of data is possible when required, right? And we understand that this is highly relevant for industries such as financial services or healthcare, where you just have to have the verbatim data, right? That's just required, right? But hopefully with this new ability to do ZK proofs, both users and verifiers will start caring more about just, you know, asking for what's needed and just, you know, starting to trust ZK technology. Okay, so moving on here, a question that I normally get when you talk about ZK proofs is, are ZK proofs stored on chain? Right? You probably relate to other blockchains such as ZK VM that Polygon is running, or other blockchains, and you would think that proofs would normally be stored on chain, or they would be stored in the form of some commitment if you're using a shield contract for privacy or other things. But the answer for us is actually no. ZK proofs are not stored on chain. The more interesting question is, you know, what can you do with these ZK proofs, right? And I would say, can Polygon ID ZK proofs be verified on chain? And the answer to that is definitely yes. So you can generate these ZK proofs directly from your device. That, in fact, kind of preserves your privacy a bit and enables you to use those proofs either on chain or off chain, right? That's like the main thing, right? So there's no concept of a block explorer for Polygon ID, right? There's no concept of you know, how much is the proof size, because that's something you're going to pay some gas to store it on a blockchain. It's more like, how long does it take to generate the proof, right? And we've optimized that a lot, and we've also you know, enabled you to kind of generate this directly from your device. So it's a little bit more like that. Okay, so what does this look like in a verifiable credentials kind of setting, right? And just a more detailed view from the previous slide where you saw the various components. Now you can see what the credential looks like and what the presentation looks like, right? So our credentials allow sort of this selective and private disclosure of data without revealing the user's main identifier, right? So you have a set of credentials. The credentials have a, let's say, blockchain anchoring, right? They have a sort of a hash or Merkle tree proof anchoring. We can dive into that in a little bit later. No information is stored directly on chain about these claims, but they are JSON LD files that are living in your device, right? Again, be that your mobile phone or be that your browser where you're kind of holding your identity wallet. So you would take those claims, again, interact with the verifier, and the verifier would ask the set of questions that I was referring to earlier, and you would generate a zero knowledge proof. Now, our zero knowledge proofs are in the form of a modified JSON Web Token, JWT or JOT. And this is something what we called JWZ or JSON Web Zero Knowledge, right? There's various standards around how to do, zero knowledge proofs using JOTs, and we're looking into that as well. But this is sort of the beginning implementation of what's possible right now with our protocol. So then the verifier will take that information and, using the on-chain information, make sure that the claim has not been revoked and that the issuer that issued this is a trustworthy issuer and the keys are valid, and a set of other set key proofs that are generated. So there's actually more than one set key proof generated, more than just are you older than 18, right? There's some proofs demonstrating that the claim has not been revoked and that you are the owner of that claim. So there's a few set of set key proofs. We can get into that later. Okay, so taking that into a little bit more detail now, we can look at some of the issuance methods that we have. And the first issuance method that we have is sort of the SIG method, which is just an issue of credentials using what we call the baby job signature, which is a lightweight signature that is used and is optimized actually for ZK proof generation. And part of the reason why that was chosen is because it's lighter to do so in a mobile device, right? You have to think about sort of the mobile device and the power it takes to generate the ZK proof. In this case, the credential wouldn't be added to the issuer's Merkle tree, and we're going to look at that later. But instead, it would just be signed with this baby job signature, which is then verified when you present it, right? So as an issuer, I could say, it would just be enough for me to publish my initial issuer state on chain, and there onwards, I would just be able to freely sign as many credentials as I like using the SIG method, right? And this is very similar to DIT Ether, which is something that they support, right? You sort of register your issuance into the DIT registry, and then you are able to generate keys, the credentials, sorry, off-chain, just, in mass, right? Without needing to spend any gas. So there's very little gas cost, or let's say, Ether cost or Matic cost, depending on which chain you're using. And all this is doing is there's taking some information from you, generating that credential, and then just you're able to generate a proof using your wallet, and the verifier validates that only the signature has been valid, right? And well, a few other things, right? It's not been revoked. The signature of the issuer is valid. There's a few other checks going on in there. So this is the lightest method to issue credentials that we have, right? The other method that we have is sort of this MTP or Merkle tree proof type of method to issue credentials. And in this one, it's a little bit more nuanced, but the validation of the proof is done against the hash that is published on chain. No personal information is shared. Again, at that point, we can get into that a little bit later. But the interesting feature about this is that the smart contract in a blockchain could be able to issue credentials, right? So by means of a set key proof, right, one party will be able to prove to another party that a set of information is known without conveying additional information. And the information about the claim is now, let's say, indirectly stored in the blockchain through a Merkle tree proof, right? Which is just the sibling path to the actual claim in the claims tree. And we're going to get into the claims tree a little bit later. But the addition of this Merkle tree allows us to store this unique root hash on chain, and you're now generating an additional proof that claim has not been revoked as well when you're doing it via this method, right? But it has the requirement that you are on chain to check that, right? So in the previous method, maybe you were able to cache the issuer state and trust it for a while. And in here, it requires a little bit more deeper check because now the issuer state is changed when you do issue that credential. So there's some nuances to that, but suffice to say, this allows a smart contract to issue credentials, which could be an interesting use case. Let's say if you are using a DeFi protocol and you want to show that you paid your loans on time, and to be able to use that in some other setting, some credit score or something like that, right? There's various use cases around on-chain credential issuance that could be relevant. Okay, so those are the two ways in which you can issue credentials, right? And now we can dig into a little bit of identity management, right? And how we manage identifiers in Polygon ID. So I think this is like the best way to explain it from this movie that I really like called Split. And there's this main character called Kevin Wendell Crumb, and he has dissociative identity disorder. He has a number of personalities, and it just kind of rotates around depending on the day, right, or the hour. But I think it illustrates it quite well, right? So the default behavior that we have, in fact, is that you are generating an anonymous random identifier for each interaction, right? And this is just to preserve your privacy. So today I might use, identifier 1, 2, 3, and tomorrow I'm going to use identifier 5, 6, 7, right? It just depends, right? And I think this is very similar to what you would have in, maybe Google Chrome when you go into incognito mode and you don't want to be remembered. You don't want to be any cookies being remembered. You just want to be a little bit more private, or maybe even going into Tor to browse the dark web, right? That's like a comparison that I would try to compare it to. But if the user does decide to be remembered by that verifier, then they will have to choose a permanent identifier, right? So this permanent identifier will, allow you to kind of be remembered by this profile, with this profile, and then the main profile, right? The Kevin Wendell Crumb profile, what we call the Genesis identity, is kind of kept hidden through these various, profiles that you have, right? So for instance, let's say Hedwig could be your gaming profile, and you will be going on to Decentraland and the Sandbox and buying some properties and some NFTs. And maybe Patricia could be your more serious, let's say, DeFi profile, and you're going into, Compound or Aave and taking some loans and using that. And so you can see how you can kind of segment your interactions on the blockchain using, various profiles, right? And I would compare this almost, yes.
Yeah, sorry, I was going to let you finish that point, but I was excited to ask a question. I was going to ask whether, can Hedwig use a credential that was issued to Patricia in those interactions, and if so, can you explain how that works? Because this sounds very cool, but if you're accidentally revealing things that still give Kevin's root identity away in those scenarios, then there's some trade-offs to be made there. So I'm really interested in how you've handled that.
So through the magic of ZK proofs, you can demonstrate that a credential that was issued to Hedwig is controlled by Patricia, right? And the reverse is also true. So because of zero knowledge proofs, we're able to demonstrate that a given credential belongs to the same set of identities, essentially.
Yeah, without revealing that all of those identities are actually Kevin. I think that being the key thing. Yeah.
Exactly.
Yeah.
Exactly. You got it. Yeah, it's an interesting feature, right? Yeah, and there's a lot of technicalities behind it, but yes, it's perhaps towards the end in the Q&A we can get into more details of that. But yes, so yeah, so this is sort of this I think very similar to what you have in Google Chrome, where you have this concept of various Google accounts that you manage, right? Maybe one is your work account, maybe another one is your personal, and maybe a third one is some association or nonprofit that you belong to, and you can sort of switch between these profiles, right? And then Google Chrome kind of segments it out for you, right? So it's very similar to a concept like that. So another key thing that we think is relevant, at least I think more so for the blockchain world, less so for the SSI space. I think this is a concept that was already kind of, deeply embedded in there, is sort of splitting keys from identity, right? So in the Ethereum world, we sort of have, the idea that a user equals a blockchain address, and we're sort of trying to change that perspective, at least in the Web3 like blockchain world. And so a user, an identifier, is in control of a set of keys, right? And you can do things such as rotating your keys, right? Or controlling multiple keys, right? This also allows us to do a number of other things, including Sybil resistance and proof of uniqueness. Kind of one person, one vote through the usage of nullifiers, which I think is also interesting. And that's a common need, I think, in the Web3 world right now. The need for, proof of humanity, proof of uniqueness. It's becoming more and more relevant. Also, the other thing is, because of you're managing a set of identities, maybe the cookies aren't being tracked by the third-party application, but now you have to kind of manage and remember who you were interacting with what profile, right? So you gotta be good at that, right? As a wallet. So that adds some complexity to the identity wallet, yes, but in the end, it kind of enhances user privacy, which is, I think, the good thing. Okay, kind of moving on to some other features. Our messaging protocol, it is kind of an adaptation of TITCOM. We call it ident3com, and ident3 is kind of the underlying open source stack that is used by Polygon ID. The communication, therefore, is transport agnostic and does not require the usage of HTTPS like you would with OpenID or OAuth, right? There's some interesting use cases. I was talking to a person in the government the other day around the use case that, they would need to be able to use Bluetooth communication, let's say at a traffic stop, to have the policeman kind of, just get some information about the user and do so over Bluetooth. And, you just kind of get asked a set of questions by the policeman, and all the policeman needs to see is a green check on his screen that that person satisfied that set of questions, right? And not just all the additional information that you would in, handling your physical documents from yourself, your car, and your insurance, right? So this is a more optimal way to do things like that, right? Some exciting potential use cases there. Some additional features as well. Smart contracts can verify credentials that were issued off-chain and on-chain. And then, the other one that I was sort of alluding to is that smart contracts can issue credentials using the MTP credential that I was mentioning earlier, right? So that's part of what we support. Okay, so now let's dig in a little bit into the claims tree. So the claims tree is a sparse Merkle tree. All of our Merkle trees are sparse Merkle trees. And the claims tree can hold either keys or credentials issued. So a claim is in the form of, I control this key, or a claim can also be, this is something about another identity, right? Which is just stating something about somebody else, right? So each claim will also have a unique revocation nonce, right? This revocation nonce can be used to revoke the claim, right? And we can look at that a little bit later on how that works. But essentially, that allows you to revoke either a key that I control or revoke a specific claim that I issued about someone else or myself, right? So that's sort of how that Merkle claims tree works. So. In addition, we have the notion of the identity state. So you were sort of looking at the Genesis identifier earlier with Kevin Wendell Crumb, right? That is what we call the Genesis identity, right? The Genesis state. So the state can be just proven directly with the main identifier, but the identity states are all published in a global identity state tree. And this is per identity, right? Not for all identities. So each identity will have its own Merkle tree. And then proofs are used to demonstrate that one of the identities is being used without revealing which one, right? So that allows some flexibility there as well. You have to kind of keep a smart contract up to date with that information. We can also look at that a little bit later. But the smart contract also has a check of state transition function. So your identity kind of rotates and it transits from one state to the other. And that when you do that, you do need to update the identity state to verify the correctness of the transition, right? There's some involvement there, but usually things such as revoking claims or rotating keys will require you to do an identity state transition, right? So there's sort of are unique cases in which you do need to spend gas to kind of update your issuer identity state. Okay, so looking at the Merkle trees that we have as well. So there are some Merkle trees that we have. We talked about the claims tree already. That you can see here. The claims tree, in fact, I know that's not like really big, but I will try my best to manage with that. Is kept private, so this red section here is all private information that you have when you issue claims, either of keys that you control or about other identities. And then you take the root of that Merkle tree, and that's public information. So when you issue a credential, you actually have the Merkle tree path or the sibling path to get to that particular claim to be able to prove the validity of that credential. And that is relevant when you're doing the MTP method, right? As opposed to just the signature method. But regardless, that claims tree root is public. The revocations tree is also, kind of public there. So you will have a set of nonces that you add as leaves to this tree that are tied to any claims that you issued, either of claims about somebody else or keys again, and you would publish that. And then the roots tree root is also public as well. So that's also a separate tree that we have. We're not currently using it a lot, but it's another tree that is available there. So this set of Merkle trees is all then hashed, and in that hash of these 3 Merkle trees is then the identity state. And again, I know that's not very visible there, but there's a smart contract that has the identity state information, and you can see the transit state function that is used to, let's say, update that identity state on chain, right? So the identity state is then a hash of these 3 Merkle trees, and then that information is stored on chain, right? So moving on to a little bit more detail around this, the revocations tree, right? So the revocations tree is the one that is housing these nonces that you sort of use to revoke claims about just traditional credentials or keys, right? So the information revealed is only unique to the identifier, right, of which those claims have been revoked. And the revocation tree is kind of housing those nonces, right? This revocations tree is going to be public. It's not directly on chain as is the issuer state. You can see the issuer state is kind of colored blue. That means that that's stored on chain. But this is instead public. So this could be in a public file storage such as IPFS, Filecoin, could be in Amazon S3, could be even in a web server, right? So we've kind of are experimenting with that a bit more, and they're pretty flexible in that regard, so that you can kind of, state where you want to, kind of publish your revocation information. So that's a little bit about the Merkle tree, that is the claims revocation. And now we can dig into, I think, an interesting comparison around the usage of zero-knowledge proofs and identity. And I think this is, highly relevant to some of the work that is out there. I don't mean this in a disparaging way against any of the other technologies out there. In fact, I'm highly respectful of all the work that's been done, obviously by you, James, and all the other folks in the identity space, Matter Labs, et cetera, that are, been working hard on privacy preserving credentials. So I'm more just using this to illustrate the kind of the trade-offs and the implication, right? So the ZK proof type obviously is snarks, right? That's kind of the base that we use. We are planning to eventually use Starks, right? That's in fact compatible with the Polygon ZK VM that's coming down the road. So that's kind of an upgrade path for our proofs. And Oncrest will use this different kind of CL, right, type of ZK proofs, which does require some larger keys for security. And then BBS has its own signature scheme, right? It's a different scheme. It doesn't exactly map, I would say, to a set key proof using snarks in that sense. Our keys are baby jub keys, which are lightweight keys, kind of optimized for mobile devices and for using less power. Anoncreds are using a link secret for the identity binding and RSA for the CL RSA signatures. And then BLS 12-381 is sort of the BBS Plus keys. All protocols allow for selective disclosure. A key difference here, I think, is that perhaps the support for predicate proofs is something that both Polygon ID and Anoncred support. And then the ability to also do the private non-revocation proofs, right? Which is something that you saw there with the Merkle tree that we have for the revocation. So we use sparse Merkle trees. This is done for operational and computational efficiency. Anoncreds does it, but I think it's a little bit different, right? It's using crypto accumulators. Perhaps a little bit of the downside of that might be that these are computationally heavy and also demand a lot of storage. So just some trade-offs in that sense. Credential issuance, we issue credentials in a verifiable credential format against an identifier, non-interactive, and they could be generated either from a mobile device or a server. Anoncreds might require a custom format against a link secret commitment, and then it might also require an interaction with an identity holder, or even a relayer, I think in some cases. So BBS Plus also verifiable credentials compatible against an identifier is non-interactive, and then the blockchain support, you can see we're EVM compatible. So in fact, you could take, the Polygon ID DID method and deploy it to another Ethereum virtual machine compatible blockchain, such as Avalanche or, Optimism, Arbitrum, etc. And Anoncreds is kind of a little bit more centered around Hyperledger Indy as a blockchain. In the case of BBS Plus, I don't think that's as applicable. On-chain verifiability, I think it's also another interesting thing. Perhaps in our case, we do kind of have that out of the box, whereas with the Hyperledger Indy, I think that's sort of already included in the blockchain anyways. You store the information there directly, right? So just a little bit of a comparison. By no means, again, mean to disparage any of the other projects. Just wanted to contrast things a little bit. Okay, so now onto the final stretch, trying to get into a little bit of what is available today if you're using Polygon ID. So again, it's fully open source. It's released under the MIT Apache license in the coming release that's in 2 weeks. And we have various components depending on what side of the triangle you're on, right? So if you're an user of credentials, you can use our Polygon ID mobile app to manage identity, manage your claims, generate the proofs. We also have SDKs for wallets that want to integrate. So that could be a mobile SDK based in Flutter that we have with a set of wrappers as well for various other platforms, including React Native and others. Or if you're using a browser-based wallet extension, you could use the JavaScript SDK to integrate into that, right? So it just sort of depends on which one you're leveraging. The issuer node is sort of the component you use to issue credentials, revoke and update credentials, manage your keys. There's a Golang server that you would host in your infrastructure, and then you would sort of install that. And you can do that directly in your own infrastructure, or we have other partners such as Kaleido, Doc, and others that are coming, where they will allow you to just call a set of APIs and issue credentials, right? And that has some trade-offs again, right? If you want to use a SaaS provider, there's some element of centralization. If you want to issue it yourself, perhaps you're more in control of it. So it just sort of depends on what preference you have, right? In industry-specific requirements as well. If you're a verifier of credentials, you can use our proof validation libraries for either off-chain. We have Golang version of that. We also have a JavaScript version, and then we also have our smart contract templates that kind of enable you to check the proofs on chain and use kind of our templates. You can expand and use that to verify proofs on chain. We have a set of partners that we've announced. So I'm not going to mention any names now. There's many of them, and more to come. These were announced at the Eth Denver event in March of this year. So more to come on this front, right? And finally, just wanted to leave you with my Twitter handle and my email for our business development team. You can contact us here. We also have the Polygon ID tutorials and the more detailed explanations behind all this available for you to use and look into it. And also wanted to introduce my colleague, Oleksander, we call him Sasha, Oleksander Brezhniev. So Sasha, he's here in the call as well, and we'll just be taking some of the questions here and kind of adding some commentary. He's our Polygon ID technical lead, and he's behind a lot of this work. I haven't been with the Polygon ID as long as he has, but he's seen it from the very beginning, so I thought it was just worth giving credit where credit is due. So that's all of that. I'll pause right here, and I'll let you ask some questions, James.
Great. Otto, thank you so much. That was absolutely fascinating. And as we were remarking just before we started the recording, I'm particularly interested, having sort of been with Evanim at the time that we were trying to deploy Anon Creds, in the wild, and many of the technical trade-offs and sort of strengths and shortcomings that you mentioned are obviously things that I've kind of lived. So it's fascinating to sort of get to peek under the hood of what a different team has done and how they've approached those same sort of sets of trade-offs with a different approach. So yeah, it's super interesting. And yeah, I did note down a number of questions while you were talking. So as the audience may remember, if they've seen any of these before, in the past we used to do these live with a Q&A, but what we found is that post-COVID, people's schedules just don't accommodate that. So I'm sure it's okay using the contact details here. If people watching this do want to reach out, then they can ask their questions that way. But yeah, selfishly, I'm going to spend a few minutes asking some of mine, if that's all right. So I'm really interested on a couple of technical questions. One is when these credentials are issued, what is the subject identifier in them? Like, assuming they are, W3C compatible verifiable credentials, like is a new DID typically spun up for each of those, or is there sort of late binding for the holder? Like, how does that work?
Yeah, so I'll sort of comment here, but I believe Sasha may expand on it. Yes, it is an identifier. So there's an identifier from the issuer, and you're sort of using one of the many profiles, right? The Hedwig, Patricia, or other profile that you have, and you're exposing that to the credential issuer, right? And then that at that point gets bound to that credential when you sign the JSON LD format. But then through the usage of zero knowledge proofs, you can use that same identifier in the presentation side, or you could use a different one, right? So that's kind of how that works. I don't know if Sasha wants to expand on any of that.
Yeah, exactly. It's like that. So user can have many identifiers and share different ones with different issues, different applications, and then use ones that he wants, essentially. Yeah.
So the protocol includes the back and forth where the holder says which identifier they'd like to use, and then the issuer transmits that credential, because that goes off chain, right? So they've got to find a way to send that to the holder's wallet as well. So all of that is done on this IDEN3Com protocol. Is that right?
Yeah, exactly.
Okay. Okay, interesting. And so what are, you said there are a couple of differences between that and DIDCOM. Can you sort of elaborate on a couple of those?
I'll let Sasha jump into this one.
Yeah, on the format side, it's more or less compatible. We have a different set of messages and how we package them. So like on the basic level, it's also like message-based protocol, and format is more or less same with DIDCOM, but the only thing is that DIDCOM itself doesn't support zero knowledge proofs, and we need to present our claims and proofs with zero knowledge proofs instead of just signing messages. So that's the biggest difference.
Okay, interesting. And I suppose that's a bit similar to why you didn't find yourselves able to just use some of the existing features in the JOT specification, as you alluded to, Otto. Like you've come up with your own variant of that, and I was wondering whether that was because there was something missing from those standards, or just because you were developing your work at more or less the same time, and those standards just weren't quite mature enough yet. I'm curious to dig into that. It sounds like interoperability is something that you plan for in the future.
Yeah, JSON web proofs.
We plan to do compatibility and to standardize the way how we sign messages. So yeah, it's essentially difference is that we are when we are sending messages, instead of signing them, we attach zero knowledge proof that it is coming from the identity that is in the message. Yeah.
Okay. Some of the work around JSON web proofs that kind of came out sometime last year from Microsoft and others is something that had just come out when we were actually developing our platform, and that's why we ended up with our JWZ kind of token standard there. But yeah, so we're open to interoperability, and as Sasha was saying, that's something that we do have in our roadmap. For long term.
Very cool. Okay. And then I guess going back to the how privacy is achieved with these Merkle tree proofs that you're using, how do you manage to avoid revealing anything unique about the credential itself? Because as you mentioned, there's obviously a path through the Merkle tree to where that identifier lives. And so, I can fully understand how you can just reveal certain attributes or certain derivations from those attributes. But how have you been able to kind of obfuscate the fact that credential from which you're sharing, say, the first three fields is not the same as the same one that you're showing the second three fields from?
So yes, Sasha, go ahead.
We have pretty large circuits on. That are proving different stuff inside this circuit, and we have private inputs to it, and then some public inputs. And as private inputs, we are feeding it with credential itself, like in a special format that is easy to consume inside circuits. It's proof that it was issued, like with a digital signature with baby jab or with Merkle tree proof. And also we provide non-revocation proof in a form of Merkle tree proof, and a few more things, and like that identity is real one, and it controls the keys and so on. And in the end, we have zero knowledge proof that is proving that request was fulfilled. That was set by the verifier. It could be like checking that some attribute of a credential is of specific value, or in range less than, more than some specific value. Yeah, and that's how it works.
So, because I guess what I'm really wondering is there any privacy trade-off involved in using the Merkle tree proof issuance method, or given that gives you the flexibility to use these credentials both on chain and off chain, like wouldn't you always want to do that because it's the most flexible way? So are there some limitations, whether it's it leaks some correlation information or something like that's inherent in going that way, or is it just that it's a bit more computationally expensive, so you may choose not to do it? Like how should people think about that when choosing which way to issue?
Yeah, so in general, we are working right now on this possibility to issue credentials on chain, and for the on chain identity, it would be the only way to issue credentials through Merkle trees. Otherwise, a preferred way is using baby jab signature, because it's essentially free issuance, because you don't need to publish anything on chain. You're just signing credentials and they're good to go.
Yeah. The other thing I'll add is that Merkle trees sort of have the advantage that you can easily prove inclusion, exclusion. So that's one of the decision points for us as well.
Yeah. So the main differentiator is just the costs. Like there isn't also a privacy or other functionality trade-off. It's literally just, doing the Merkle tree thing requires updating some state, and so you've got to pay gas for that, and you can decide whether you want to do it or not. Yeah. Did I get that right?
Yeah.
Yeah.
I think so.
Okay. No, that's fabulous. It's really cool. Okay, cool. And then so back on the subject of the DID method itself. So obviously there's a couple hundred DID methods already. So I've got two questions. One, is your DID method registered? Is it in the universal resolver? Can sort of people go and use it now? And two, what was it that you felt drove the need for a Polygon ID specific DID method versus one of the 200 others that currently exist?
Yes. So yes, our DID method is registered with W3C. We did implement a resolver through the Decentralized Identity Foundation DIF Universal Resolver. I believe, well, at least personally, in my opinion, I'll let also Sasha chime in here, but their usage of Merkle trees is so unique to this DID method, and the sort of the set case snarks that we're implementing kind of justified the need to create its own DID method. But it's, again, fully open source, it's Ethereum compatible, and you could port it to any Ethereum chain. So we're open to working together with the community. It's all about user choice, into which DID method you prefer. I personally subscribe to the idea of identity wallets supporting multiple DID methods. I have already been in a world where Web3 wallets already support multiple blockchains, right? So you're going to have your Solana NFTs, your Avalanche tokens, and you're going to have some tokens in various Ethereum L2s, such as Polygon or others, right? So I believe there's sort of also the same kind of situation in identity wallets, right? Multiple DID methods. But I don't know, Sasha, if you want to add anything here.
Yeah, I totally agree with that. Yeah.
No, I mean, I definitely agree as well. I think it's inevitable, and so that makes a lot of sense. So going back to something you said kind of towards the end of your presentation, Otto, you mentioned how sort of there's a contrast between sort of the way the blockchain community sees things and the way the SSI community sees things, and that SSI community already separated keys and identifiers, whereas blockchain communities just discovered this like fantastic privacy enhancing feature. What my sense is that that's one of just many things that these communities could learn from each other, and I do think it's both directions. Like, is that something that you've experienced as well? And can you think of other things that you sort of wish these two communities would learn from each other?
Yeah, exactly. We need to get away from this concept of a user equals an Ethereum key. And the other thing, which is sort of unfortunate that I've seen, at least in the Web3 world, is sort of soul-bound tokens as like a placeholder for verifiable credentials. And that's just like not, going to preserve your privacy, unfortunately. I subscribe personally more to the idea of a verifiable credential giving you the right to then generate a token. That's sort of like that linkage between a credential and a on-chain NFT or soul-bound token is interesting. And I think there's sort of the emerging concept of an identity-bound token. So let's say I am a Solidity expert. I've learned to program smart contracts. I have a verifiable credential that's living privately in my wallet. But if I want to have a social signaling mechanism to show to the rest of the world and kind of brag on the street that I have this degree, then I can mint an identity-bound NFT that's tied to that identifier, right? And so, through perhaps a ZK proof or other method, I could then transfer on to another address if I choose to do so, but it's not like, let's say, stuck on a given blockchain address. So yeah, there's things like that where I think we can sort of work together. There's a lot of companies just doing soulbound tokens or doing some minimally on-chain, inflation, but that's just going to lend to correlation, right? I think in the end, long term. But yeah, there's I think there's, as you're saying, things that both sides can learn.
Yeah. No, definitely. And so, so how are you thinking about adoption for this? Obviously, you mentioned a number of partners, and I know you've got more announcements in the works. But are you seeing this as purely as an infrastructure play, and you're hoping that people will think these are interesting capabilities and they'll go build stuff, or are you focused on attracting, say, issuers or holders or verifiers? And if so, the title of this presentation was included both Web2 and Web3, and so how are you thinking about how you invest in those two very different sets of use cases? I think adoption is a question that people watching these webinars often come back to, and I'd love to get your sense on how you're planning to solve it.
Yeah, so I'll be very honest. I think that at least we see a lot of really pressing needs in Web3 for verifiable credentials, just because we have things such as token farming, where people just, amass tokens and by having a set of blockchain addresses all over the place, or they'll go into a DAO and they'll, game the voting in the DAO proposals. So this online cooperatives, right? And so they'll be like, gaming the system and sort of the meme of, in the internet nobody knows that you're a dog, becomes true, right? At least in our world. So I think there's a lot of pressing needs for proof of humanity and proof of uniqueness, and we think that's like our priority area. But we're also getting a lot of interest from Web2, sort of use cases as well. So I think it lends itself to both, but we think there's more pressing needs in Web3. Sort of in the sort of, who are we out there to integrate with? We're out there to integrate with everybody, right? So the Polygon ID app is out there, is available, but we want, everybody out there that has a wallet, be it a Web3 specific wallet or an identity wallet, to integrate with us, right? And be kind of Polygon ID enabled at that point. And it's also in the sense of issuers, we're willing to work with a set of SaaS providers that make it easier to issue credentials. And we want, as many verifiers as we can get in our platform. So we're sort of kind of building that ecosystem. What's unique to us, perhaps, is the fact that we already have an existing ecosystem that we can sort of tap into. And so if you're already using the Polygon blockchain, like the next perhaps logical step would be to try to use Polygon ID when you're doing so, right? So that's sort of like a different situation for us, where we have this ecosystem that we can try and sort of get some adoption from them.
Yeah, no, it is a big ocean to boil, isn't it? As you said, there's need all over the place, and so figuring out where to focus is really challenging. But from what I've heard, there's quite a few differentiated capabilities here, which should make this really appealing. So that's super cool. Gosh, look, I could go on for ages, but I'm conscious that I've peppered you with questions for like 20 minutes here. Are there any sort of final parting comments or remarks you'd like to make before we wrap this up?
I mean, I think this is a very powerful tool. We're by no means the only identity protocol leveraging ZK proofs. There's a number of others out there. Some are using verifiable credentials, others are doing different approaches to do this, right? And we think this is kind of a option out there as well. And I think it'll be more and more relevant over time. People will start caring more and more about privacy, right? So, in the Web2 world, there's been all of these data exploits, but in the Web3 world, there's things called such as doxing your address. And, I'm sure, people are already concerned about that, and rightfully so, right? So I think it's an option that's out there. We're looking to support the values of SSI, and allowing people to be in control of their data more than they are nowadays with the intermediaries and others, right? That kind of just take advantage of this position that they have. I also want to commend the work from Oleksander, Sasha, and his team on doing this. I think it's been a titanic effort, and now that the full stack is open source and out there, I think it's a great contribution to the industry, and we're looking to engage. I don't know, Sasha, if you want to add any comments.
Yeah, we're trying to standardize our things and get feedback from community to improve.
Perfect. And we're honored to be here. We really appreciate you guys inviting us. It's great. We really appreciate it.
Well, it's been incredibly exciting to learn about what you've been up to, and as you said at the very beginning, people don't care enough or don't seem to value privacy enough. But the trade-off doesn't have to be made such that the privacy isn't built in by default, right? I think that if we make it so that the user experience is just as great, you've got all the capabilities you need, you've got interoperability, you're not losing anything, then of course people will choose to have privacy on top. And so that's why I think it's important that we keep pushing the envelope here and advancing the state of the art of what's possible. So I think it's fantastic to see this work out there in the community, and I'm sure, in addition to on the socials, I'm sure people can find you at Decentralized Identity Foundation and IIW meetings and things like that, right? You guys are on the road a fair bit, I would imagine.
Yeah, I'll be attending IIW in November. And yes, we're interacting more with forums such as the DIF and others, where we're hoping to contribute, both this work and other work such as, CK verifiable presentations, interacting with others, proposing the JSON web proofs and others, so that we can contribute to the space as well.
Fantastic.
I have the standard SSI slide. I don't know if SSI meetup slide.
Yeah, by the book. Well, gosh, I mean, with the rate of innovation in the space, there's clearly going to need to be an update to some of these. But I'm really happy to have had this conversation, Otto and Sasha. Thank you both very much for your time. It's been great, and I hope that folks who've watched this have found it useful. They know how to reach you if they need to, and we'll be back soon with another interesting SSI Meetup webinar. But in the meantime, thanks everyone for your time.